This is the second video for October 27th, October 30th, and we're looking at the law of sines and law of cosines. On the last video, we finished here talking about how we could use law of sines. Now we could do that to solve for our value x, which is an angle. And because it's an angle, we know that we'll have to use the inverse trig function, in this case, arc sine. I'm going to go ahead and flip to the back side. Probably go through two more. And then we'll go from there. Oh, a little corner of the book. There we go. All right, so here we're trying to solve for x. We have multiple angles. I'm going to write the two formulas at the top. But the idea here, again, is that if you have multiple angles, then the chances are, because you have law of sines, you have 1, 2, 3 angles that we can use. Here you have 2 angles. So because of that, the chances are that we could, it's more likely that we will use law of sines versus law of cosines due to this one angle here. And so let's go ahead and set this up. I'm going to go ahead and, because x is here, I'm going to label this a, big B, little b, big C, little c. So then if we plug these values into law of sines, then we would have sine of 61 degrees over x, our value x here, equals sine of 48 degrees over b. We don't know what the value for b is, so we'll just keep that as b, equals sine of c, big C, over 21 centimeters. And when students did this problem, what they noticed is, I think I mentioned in the previous example, here, if it's law of sines, we can ignore one of those pieces. We'll have to keep this because we're solving for x. So either we can ignore this with the b's or this with the c's. But students said, well, I need to know, we don't know what little b is, so I would need to know that to use this piece, or I would need to know big C to figure out this piece. And so if we look, there's no real way that we can figure out what little b is. However, because we're already given 2 angles of a triangle, we can figure out what big C is. So we could do 48 plus 61. That would give us 109. And because all 3 angles of a triangle add up to 180, we can subtract 109 from 180 to get us 71. Which means that C here would be 71 degrees. And I'm going to go ahead and erase C here and put in 71 because now we know that information. And because we're solving for x here, we don't have any unknowns in this piece. We don't know what b is. We can ignore that piece of the equation and just have this here. Oh gosh. Oh my gosh, my lead. It's combusting. And now we can solve for x. A lot of different ways we could solve here. I'm going to draw a line so I don't overstep bounds. A lot of ways we could solve here. I would highly recommend doing this on your own first and then watching to see if you get to the same place. I'm going to go ahead and solve it. If you have questions about it, please ask. We'll also get more practice with this on the next day on October, I don't know what that is, 31st and November 2nd. But because we have x in the denominator, I want that out of the denominator. So I'm going to multiply both sides by x. Because if I have something in the denominator and I want to get it out, because this is like division, I can multiply and these x's would go away. And we would have sine of 61 degrees left on the left-hand side. On the right-hand side, when you multiply fractions, you multiply straight across. So it would be x times sine of 71 over 21. And now if we want to continue solving for x, again, we have x times this divided by 21. So we want to move the 21 because we want to get the 21 out of our denominator. So I'm going to multiply both sides by 21 as well. Again, if you solved it a different way, that's fine. Stay with me. See if you end up with the same thing. On the left-hand side, though, when I multiply this, nothing that we can really do. So this would be 21 sine of 61 degrees. On the right-hand side, the 21s would divide out, and we would be left with x times sine of 71 degrees. And now if we look, man, I don't know what's going on with my voice today. If we look here, what we can do is divide both sides by sine of 71. Here, the sine of 71s, they would divide out. And our solution would be x equals, again, it's not going to be pretty. There's not really anything we could do here to simplify, but that would be our solution. One thing I want to mention here is that these signs, some people are like, well, we have one in the numerator and denominator, they cancel. But it's sine of 61 degrees, sine of 71 degrees. Because those values are different, these functions would evaluate to different values. So these do not divide out as they would here. Because it's sine of 71, that's why these would divide out. Here we can't do that, so that would be our final solution. Okay, one more problem, and I'm going to encourage you to do the rest on your own. Here, so again, we could do law of sines versus law of cosines. I'm going to keep that up here. Again, notice law of sines, 1, 2, 3 angles we could use. Law of cosines, just one. Here, we're given this one angle. We can't figure out what these two are because we don't know anything else about the triangle. But we can't say, hey, subtract 180 from 42 from 180 and then divide by 2. That's not going to be true in terms of what these angles are. So because we have this one angle, chances are we're going to use law of cosines. And when we plug it in, we'll see if that's true or not. Now, one thing I mentioned to students is here. Notice that our angle that we have is A. So when you're using law of cosines, be really intentional on how you label your triangle. So here, I would label, I'll do it inside. I would label this as big A because that's the angle that we're given, and we're going to need that angle here. From there, it doesn't really matter. We can call this big B, or you call that big C, whatever. It doesn't really matter in terms of your calculation. Big C and little c. Now we plug it in. Instead of a squared, a is now our x. So we would have x squared equals 22 squared plus 17 squared. And instead of a, our angle measurement is 42 degrees. Now, when you're doing law of cosines, you need to think about what can I do to simplify? Here we have our x value here, but we need to simplify everything over here on the right-hand side. So what we could do is square these values. 22 squared would give you 484. 17 squared would give you 289. Then we could multiply these three values. When you're multiplying those, do not distribute, just multiply each of those three together. So you do 2 times 22, enter, times 17, enter, and get 748. And when students did this, we talked about, can we simplify further? Some students said, yeah, we can add these two numbers, subtract this, and leave the cosine. However, we need to be thinking about PEMDAS. Multiplication happens before you add or subtract. And what's happening here is we're actually multiplying these two values. So before we subtract these, if we add these two, we can't subtract this value here until we multiply. And we can't multiply this because we don't have a powerful enough calculator. So we'll actually leave this as is, But we can add these two numbers. And if we add those two numbers, what you would get is x squared equals 773 minus 748 cosine of 42 degrees. We can't simplify any further, and so we get x equals, taking the square root of both sides, 773, square root of 773, minus 748 cosine of 42 degrees. And that would be your solution for that problem. If you have questions about this, please ask me. We'd love to answer those questions. I would recommend trying this problem. Give you a hint. You have this one angle. It might be beneficial to change the name of this angle so that you can use one of the formulas more effectively. If you have questions, please feel free to ask me. I'd love to answer your questions. We'll also go more in depth in terms of word problems in the next class on October 31st or November 2nd.